to help other people. Our next speaker is Ryan Jarvinen, who's going to talk about OpenShift and clustering Node.js on OpenShift, which is kind of a neat thing.
Hey guys, how's it going? I have, partial access to the internet. All right. Part of this demo was going to be related to IRC bots, and we'll see if this works. The bot's online. All right, we'll see. Okay. So I'm going to talk a little bit about using OpenShift to scale Node.js. I have a couple links here to these slides. They both go to the same place. One's a so cute URL, so it's a little bit more human friendly. And my name's Ryan J. or Ryan, and I work for Red Hat, who is also hiring. So I'll zoom through this stuff really quick because I hear we're kind of short on time, but I'll cover a little bit of like cloud basics and what is OpenShift. How many of you guys have heard of OpenShift before? Well, good. Like about a third of the room. How about OpenStack? More people on that? Little bit more, maybe. Okay. All right. Cool. Good to know. All right. It will cover what a horizontally scalable application architecture looks like. Hopefully, some of you guys know what that is. And I'll probably skip over spinning up a new app. I spun it up in advance, so maybe we'll be able to interact with it. And we'll look at how to scale using OpenShift's tools. So here's a quick kind of cloud overview. You have infrastructure as a service at the bottom, a platform as a service, and then software as a service. That's what you guys develop up top. The end user is non-developers. In the middle here, you're actually writing and running your own code. And that's really where OpenShift is trying to focus. They'll help you auto-scale applications and basically provide kind of horizontally scalable web architectures on demand. It's open source, so it's free as in, free as in beer because it's no cost and there's no time limit on the our Red Hat's hosted version of it. But free as in freedom because it's all open source. The goal with this is really to provide something that a platform as a service that anyone can use in their own internal development shop. So let's see. We have currently OpenShift Online is our hosted version. That's in a developer preview right now. In that developer preview, you could get 512 megs of memory and a gig of disk space per app, basically for each of our app containers. And what these app containers, what we usually call them gears. And the interesting thing about this is what we do is we slice up your whole box and give you kind of secure application containers within that box, right? And the tools we use in order to pull this off is Security Enhanced Linux, which was developed by the NSA, and C groups, right? Those two things together, we can make like a jail for your app to run in, and then C groups lets us monitor everything in that jail and say, monitor what's the number of persistent network connections, how much CPU load, how much disk space is being used, all at a kernel level, right? So we've completely removed virtual machines from the picture, but we can still do secure multi-tenant hosting. It's secure enough. We provide SSH access into each of these instances, and if I have time, I'll SSH into one of them. So OpenShift Origin is up top. That's the full open source version, and that's our upstream master for everything. We've got OpenShift Online is Red Hat's hosted version. It's currently being hosted in Amazon EC2. And then we have, of course, because it's Red Hat, there's an enterprise version where you could pay them a lot of money, right? So here's a sign-up link if anyone's interested. Here's a download link for OpenShift Origin. If you wanted to try it out on your own laptop, we have virtual machines, a live CD you could download. Lots of good stuff there. And our main integration point for back-end data stores, currently we have MongoDB, MySQL, and Postgres available for back-end DBs. But the idea with these cartridge specifications is you could package up anything you want. So if you wanted to have, for example, a consistent version of MySQL across your whole development workshop, your ops team could package that up as a cartridge and then make that available to the developers. So the cartridges are kind of that metaphor of this is something easily scalable that the developers can grab. I'm actually working on a updated Node.js cartridge for OpenShift. The benefits for that, what OpenShift is trying to do for that is we'll read your package.json file, we'll look for the engines attribute in there, and if you have a specific version of OpenShift defined in your package.json, we'll pull down the latest source and build that for you. So really advanced kind of build process. If you're going to spin up a new app, I would consider checking out this link here. I have a pull request. I'm trying to get this merged in as the main official version, the auto-building versions of Node as our default. But if you see a couple examples in here that mention Node 0.6, that's what we're currently shipping as the default. So this is basically your way to get any version of Node you want all the way up to 10 and beyond experimental versions, as long as they're available on the web. This is a big splash of everything you could do on OpenShift currently. There's also kind of custom DIY cartridges where you could build out whatever you want. Like I said, you could package up a specific version of Node, specific version of MySQL. There's a OpenShift open source client interface. So if you were hosting this in your own private cloud or in your own colo, you could use the same command line tools to deploy to your own private cloud. And yeah, I'll skip through some of this stuff. So scaling. All right, here's scaling. All right. Basically two ways to scale. You could go vertical, right? You could get bigger machines, bigger hardware. This may work. It might also be expensive, right? And there's a limit to how big you can go. If you want to buy like Cray systems or something, great, but you're going to be paying a lot of money to try to go just vertical. So really, you want to scale horizontally. You want to swarm your problems and distribute your load and hopefully have a linear growth as you scale horizontally. So what do you need for horizontal scaling? You need commodity hardware. OpenShift really doesn't care. We're trying to run on top of OpenStack. You could run OpenShift on bare metal as well, but the goal is really to be kind of like the platform as a service on top of OpenStack and have an open source standard all the way down to the floor, down to your hardware. No proprietary components unless that's what you want to include. You need to be able to easily create and destroy instances. And your software needs to be written to grow sideways. So there's a couple tricks we could look into. This is kind of an overview. I know this says JBoss, but that should be a node container. These gears are basically, where it says node here, those are basically worker instances. It's a whole box that's sliced up using security-enhanced Linux and C groups in order to have secure containers, and then those will be kind of worker applications, right? And then as your, one thing OpenShift does is it can auto-scale your apps up and down across your OpenStack cluster. So here's a new empty instance there that's ready to be sliced up. And I know it says RHEL here for Red Hat Enterprise Linux, but you could also run OpenShift on Fedora. I've heard of people running it on Gentoo and a couple other Linuxes. And like I said, OpenStack is the intended target. So really any Linux that implements OpenStack and has C groups and SE Linux available. So here's kind of your application scaling group is going to be your middle tier here. I know it says Java, but those are essentially could be node instances or any type of application code. Anytime you put it in a scaling configuration, we'll automatically have a HA proxy load balancer up front. And I just added last night some hooks to be able to talk to HA proxy and identify your siblings right in Node.js. So I'll do a quick peek at that in a minute. So scaling tips. Go stateless with your application containers if you can. Move session state to the back end, to a Redis or React or something like that, MongoDB. If you can put your session state on the back end, you can quickly delete and create new instances and not have to worry about the session information. OpenShift by default has sticky sessions, so we always route to exactly the same instance. So you get a easy set of defaults, but you can turn off the sticky sessions and try to go stateless as well. For scaling, you want to build with reusable, loosely coupled pieces, of course. Design for failure whenever possible. Make these kind of workers pluggable. And borrow from the best technologies, right? So let's see. Here is a couple examples. OpenShift, I'm going to copy and paste this into my command line and try to scale up the instance that I have. I have an app that I created called Node PDX Bot. I'm going to say Node PDX Bot to go up to a minimum of 3 instances. So this is the command line interface that I could run to set a min and max for my app. You could also use a web interface and set it in here. These are actually, once you SSH into your gear or your application container, you could run these commands inside to trigger a scale up or scale down event. So that means from Node, you could shell out and say, give me another instance, right? Shell out and just run HA proxy CTLD up or down if you wanted to control it from within your application container. But cgroups gives you kernel level monitoring of all your network connections, memory, disk usage, CPU usage, all that stuff. So that might be more efficient than trying to monitor it using Node. So up to you, but if you wanted to turn off this HA proxy and actually have Node do all the management, you could do it there as well. There's also a REST API for triggering all of these and for pulling a lot of great metrics from the kernel, right? Here's a couple links for HA proxy web UI. Let me see if I have an example. So here, I just told this app to scale up. Ooh, it's not doing good. Red means that it's in a down state. Over here, I've got here's another app that I spun up earlier. So all these are green, they're all working, and it looks like I have, I think, 16 or 12 instances here that are all running in a cluster. And I can actually go to oh, no, that didn't go there. You can actually go directly to any of these instances, and here's a CSV dump of all the HA proxy status. So this is what I hit this endpoint in order to basically identify the sibling nodes. Let's see. So when your app spins up, you automatically get a publicly addressable DNS, unless you run this behind a firewall or something like that. Let's see. Get back to finish off my slides here. I had a app that I was going to spin up. This is kind of what it looks like as your app spins up. You'll get your a Git repo in your OpenShift gear, a local Git repo. Node is used as the web server in this case. SSH access, logging, publicly addressable DNS, and a custom build of Node all come up in about 5 minutes under good network conditions. I'm not doing it here because network's been really iffy today. And then if you wanted to add in cartridges or these pluggable services, this is kind of how you do that from the command line. It's also available from the web. It's basically one command, and you've got a Mongo backend. This is how I write my apps, so I could run it locally or on OpenShift. There's basically 2 things you need to do if you wanted to port an app to have it be able to run on OpenShift. Once you do that, it's basically one click or one command for someone to spin up something directly from source on GitHub. I think I had a slide. It's back one. No, back another one. I had an example in here somewhere. Anyway. that is, I think, about it for me. This will basically allow you to try to read the OpenShift variables that we supply via the environment. If those aren't supplied, then I default to a localhost condition, and then I could run my code in either case, right? Let's see. It's going to generate some load and scale the app up, but I'll skip that part. I did add some code for cluster sibling awareness, and I published that in an NPM module. It's from the hackathon last night. And I think that is all that I got. If you want more information, hit me up. I also have some free junk from Red Hat, some USB key / bottle opener combos and some stickers if anyone wants it. That's about it. Thanks for listening.